Okay, gang, here we go. Here is the final hurdle before the end of the semester, mixed compounds. So we're going to take everything we've done so far. Ionic, meaning we've got, binary, we've got transition, we've got polyatomic, and then we've got covalent compounds, right? And then we've got acids. Yeah? So what you need to be able to do is if I give you a compound, either by name or its formula, you should know whether it's ionic, covalent, or an acid. And then you have to be able to either name it if I give you the formula, or you need to be able to write the formula if I give you the name. Okay? And this takes quite a bit of practice because you can't allow yourself, in all the other videos so far, you've kind of just been able to learn the rule for that video and then just get into a pattern of doing it over and over again. But now you have to think about which rules you need to apply. So really pay attention when you're doing these. Okay, so here's just, remember, this is purely to help us remember how to identify. Okay, so refer back to this when you're trying your practice. Okay, if it's ionic, remember it's going to be a metal with a non-metal. So if it forms a cation and an anion, it's ionic. Okay. If it's an acid, you're going to form, it looks like an ionic compound, but the cation will be an H. Okay? And then if you have, and then your ionic, your anion could be any of the regular anions, right? And then the covalent compounds, remember, are all the nonmetals. So these are the things on the right side of that stair-step line. Now, there's one huge exception, and that's if you have a compound with NH4. Okay, remember NH4 is one of our polyatomics. So this is the only positive polyatomic that we expect you to be able to recognize. So you could have like NH4Cl, right? And this looks like it's nonmetal because nitrogen, hydrogen, and chlorine are all nonmetals, but really this is ionic, right? Because the NH4 is one of our polyatomics. So you're going to name that as a polyatomic ionic compound. Alright, so here we go. This first part, all we're going to do is go through and identify whether each of these things are ionic, covalent, or an acid. Okay? So, Na2S, well, sodium is a metal. Okay? So this is a metal, and this is a nonmetal. Alright, so that means this guy has to be ionic. Okay. Specifically, this is one of your binary ionics. Alright. Now, NO3, well, you guys probably recognize this is one of our common polyatomics, but because we don't have a charge here, you know it's not a polyatomic ion, so we're just going to name it as covalent, because nitrogen, both of these guys are non-metal, right? So this is covalent. Alright. Now, this guy here, notice how we've got the NO3, so this is our polyatomic anion, but we're starting with an H. Remember when we said H is our cation, we say this is an acid. Okay, so we're going to use our acid rules. Alright, now we've got a metal with a polyatomic ion. Okay, so the metal, right, is going to form a cation, the polyatomic ion is our anion there, so this is ionic. And then we've got manganese and chlorine. Manganese is a metal, right? And Cl3 is a nonmetal, so this is also ionic. And then finally we have NH3, okay? And N is a nonmetal, H is a nonmetal. Notice that we're not starting with an H, so we're just going to assume that it's covalent. You could also name this as an acid, but I'd probably accept either one, unless I specifically told you name it as a covalent compound. So make sure you're just reading the directions. Alright, here we go, where the rubber meets the road. So we got Na3PO4. So, we have to decide what it is. Well, we know that sodium is a metal, and this guy here, PO4, is our non-metal. This is our polyatomic. Okay, so Na3PO4, so this has to be an ionic compound. Okay, so for ionic compounds, we write the metal as normal, so this is just sodium. and then the polyatomic is phosphate. So sodium phosphate. Okay, this one C3PO or C3P4. Okay, so this is carbon is nonmetal, phosphorus is a nonmetal. Okay, so really now we're going to do the covalent naming. Okay, so we write how many we have first. So we have a tri, and then the first one gets its normal name, carbon, and then 4, which is tetra, and then the second one, remember we turned into the ide version, so this turns into phosphide. Tricarbon tetraphosphide. Okay, now zinc here. So we've got zinc, which is a metal, sulfur, which is a nonmetal. Okay, so we've got zinc. Now, if you look at your periodic table, you see zinc is a transition metal, right? So we have to figure out what the charge is. Well, we know that sulfur, usually it makes a charge of 2 minus, and because this is a 1-to-1 ratio, we know the zinc had to have been 2 plus. So we're going to put in Roman numeral 2 after the zinc, and then the sulfur turns into sulfide. Right. Now we've got calcium and chloride here. So calcium is a metal, and it's not a transition metal, so it's just going to be good old calcium, just normal. So you got calcium, and then we've got our nonmetal, which is chlorine, and so it just turns into chloride. Right? So just to recap here, because I've forgotten to do these are, so this guy, remember, was covalent. This guy here was ionic. This guy here was also ionic. Right? So we've got Br5O10. Well, bromine and oxygen are both nonmetals, so we know this has to be covalent. Okay, so we're going to put the prefix first, which is penta. Penta, bromine. And then deca oxide. You could also put decoxide, but either one's acceptable. Cool. And this guy here, H2S, well, this is ionic, right? Because we got a cation and an anion, but notice we're starting with an H. So therefore it has to be an acid. Okay? So with acids, remember, if it's non-polyatomic, okay, or with acids in general, when we're starting with the formula, we're going to name the anion first. So this would be a sulfide, right? This would be hydrogen sulfide. Okay, so we're going to take the ide, and so we know that we have to write hydro first, so this is hydro, and then we take the stem. Remember, sulfur is the weird guy, so we're just going to write sulfur, and then the ide turns to ic. Okay, so this is hydrosulfuric acid. Okay. So as you can tell, you kind of have to bounce back and forth from one to the other, You just kind of always got to stay on top of where you're going. And so this is really the trickiest part. And the only way to get good at it is just to do practice after practice after practice. Now I'm going to give you the name, and then you write the formula here. Okay, so right away we should see, oh, we've got deca and then we've got tri, so that means this tells you right away this has to be a covalent compound. Okay, so you're really just going to recognize, okay, we've got sulfur, we've got iodide, okay, which is I, so deca is 10, iodide is 3, so S10I3. Yep. Okay, so vanadium, well, that's a metal, and specifically you see the Roman numerals, so you know it has to be a transition metal. Okay, so vanadium, and they tell us that it has a charge of 3 plus. That's what the Roman numerals mean, right? And then we have phosphide. Well, that's phosphorus, and it also has a charge of 3 minus based on where it is in the periodic table. So you can crisscross, or you can see that they're in a 1-to-1 ratio, so this just becomes Vp. Yeah. Okay, and then sulfurous acid. Alright, so we know we've got an acid, so that means we're going to start with some sort of H. Now we have to decide which kind of acid it is, remember. So here's our us, remember, so that means this had to come from our ite. Okay, so we just write the stem, oops, and then write the ite. So it's sulfite, right? And so sulfite is SO2. Nope, I lied. SO3. And then the charge on a sulfite is, let me just double check because I don't want to screw it up. Sulfite is 2 minus. Okay, so it's got a 2 minus, and since it's an acid, we're going to put it with an H. H has a charge of 1 plus, so we know we need 2 hydrogens for every 1 sulfite to get them to match up. So at H2SO3 is our sulfuric acid. Okay. Now we've got silicon monochloride. So right away you should see this mono and know that it's covalent, right? Oh, I forgot to do it again. So this would be ionic. You don't have to put these, but this might help you when you're naming things, just to identify which one you're talking about. Okay. So anyway, so we've got silicon, which is Si. Notice that there's no prefix here. Okay. There's no prefix, so you know there's only one of them. And then monochloride, so that's just Cl1, but the 1 is understood, so you just leave it as it is. Okay. And then we've got barium nitrate. Okay, so barium is a metal, nitrate is a polyatomic, so we know this is ionic. Okay, barium has a charge of 2 plus. Okay, where did the pen go? So we've got barium, charge of 2 plus. Nitrate is NO3 minus. So now we see that we need 2 nitrates to match 1 barium. Okay, so remember, this is where we need to make sure we put the parentheses to emphasize the fact that we need 2 nitrates to equal 1 barium. So it becomes Ba parentheses NO3 N parentheses 2. Alright? So there's lots and lots and lots of practice to do in that packet. I suggest doing lots of practice over and over and over and over and over again, just until you get really used to which rule you need to apply when. And that's it. Last video, last checkpoint of the unit. You did great.